Hello everyone, welcome back to the AAS YouTube channel. And as you all probably know, we are doing something historical, useful, and probably fun in about 20 days, where we'll have the AAS plus Laboratory Astrophysics Division, LAD, dual meeting. It'll be virtual, it'll be online. And I am super happy today to have the LAD chair, Phillip Stancil, with us. Hey, Phillip.
Hi, everyone.
How you doing today?
Doing pretty good. Great to be with you.
Great. Where are you at?
I'm in my home office in Lawrenceville, Georgia.
Lawrenceville, Georgia. Okay.
Outside of Atlanta.
So you're actually at the University of Georgia, Athens, right?
That's right.
Okay. Very cool. What do you like to do for research, Phillip?
Well, I am atomic molecular physicist, computational. Most of our work is related to astrophysics, hence I'm in the Laboratory Astrophysics Division. How far do you want me to go into details? Or?
Well, what sort of energy ranges or wavelength bands do you cover?
Good question.
You do X-rays, infrared, all of it?
All of it.
All of it.
Yeah.
Okay, radio?
Yes. Well, so we mostly do atomic collision processes, molecular collision processes. Okay. And so we're interested in anything from the radio to the X-ray. Mm-hmm. Depends on the relevance of the process. So, you know, for example, we are interested in X-ray emission from charge exchange. Okay. Collisions of highly charged ions with neutrals, which emit, you know, in the low X-ray range. Uh-huh. And will be particularly important when CRISM gets launched, coming up.
When is the launch date for that?
I think it's next year, I think.
Okay. Okay. Yeah, that'll be awesome. That'll be cool.
While the other extreme, we're interested in molecular collisions, which have much lower energy scale in the rotational transitions down in the radio, up to vibrational transitions in the infrared.
That covers a pretty wide swath of astronomy between that range there. So, how did you get into this field? How did you get into AMO?
Well, curiously enough, I started as a polymer physicist as a graduate student.
Really? Okay.
So I was working at NASA Langley, and what we did was we take little samples of polymers that were candidates for materials for the space station. And we put it in oxygen plasma.
Okay.
And then I took optical spectroscopy of the resulting emission.
Yeah.
And I just said, well, now this is 1990.
Okay.
How do I get information to analyze this spectrum? So I spent time digging through journals because databases weren't available then.
Yeah.
I just was interested in the atomic molecular physics. And so then I decided to get out of the lab and switch to computation.
Cool.
That's how it started.
Very good.
My first project was to look at two-photon emission of hydrogen.
Oh, okay.
And strong magnetic field.
Yeah, yeah.
White dwarf field strengths, 100 megagauss.
Mm-hmm.
Yeah. So that then led me into astrophysics.
Very cool. Very cool. That's a nice process. All right. So you're chair of LAD. How long have you been chair of LAD?
For 1 year. And the way it works, we start out as vice chair for 2 years, and then we transition to chair for 2 years.
Oh, okay.
So I'm about to have my first meeting as chair.
Okay.
Yeah.
Very cool. So what is LAD? What is the mission of LAD? LAD is one of the newest divisions in the AAS. It's probably no more than 7 years old at best.
That's right. Yeah, we were founded in 2013. Before that, we were a working group.
Okay.
And we are the newest, so we're the smallest at the moment. We hope to change that. So one of our missions is to bring together laboratory scientists, and when I say laboratory, we mean both theory and experiment. Laboratory scientists studying atoms, molecules, nuclei, surfaces, bring them together with astronomers, observers, and modelers to try to have, communication, what is needed to advance our understanding of the universe.
Mm-hmm.
One of our goals, of course, is promote the critical need of these fundamental processes to the community, both the users and well as new upcoming students and early career scientists. It's a well-established historical field, right? Was at the beginning of modern astronomy, right?
I am reminded of a famous painting by Raphael called The School of Athens, where Socrates and Aristotle are walking, and
the other Athens.
Right, and one of them is hands down, meaning we do stuff on the earth, and then the other one has got his hands up, meaning maybe the inspiration is from the sky. So your comment there just reminded me of that tight relationship between things we do terrestrially and how we might relate them to the cosmos.
Correct.
That idea goes back at least to Raphael.
Yeah.
So it's new. So roughly how many members are currently in lab?
We're about 180.
Okay.
Oscillates a little bit.
Okay, so there's plenty of room for growth there to get on par with, let's say, some of the bigger divisions. I might be the high energy astro division head or DPS.
Right.
To the point where DPS essentially has their own journal these days. We just launched the Planetary Science Journal. So maybe one goal of LAD in years will be to have its own specific journal, that we get enough growth to support that. So
that is a good idea. There is a new journal now.
I just gave you a great idea to go for, right? In years, we would love to have our own AAS journal, Laboratory Astrophysics. I'm just making that up. But
there's a European journal now, the Molecular Astrophysics Journal.
Ooh, okay.
Started a few years ago.
Okay. Okay, cool. Okay, well, there's a great goal for LAD. Get our 180 memberships up. So I'll be explicit. So you really want to join LAD. It's really cool. So this year, and I believe last year, LAD had their annual meeting in association with the AAS
summer meetings.
Okay.
Yeah, historically, we've always had our meeting with the summer meeting.
Okay.
The general summer meeting.
Good leverage at this point. So what are some of the advantages of joining LAD? Sort of answering the question, what's in it for me, right? So if I was a grad student or a postdoc coming up, or even a seasoned researcher, right? Why would I want to join LAD for the $10 or so that it costs to join the division?
Well, this is a good question, as the debate we had within the division.
Okay.
So since its founding, we have been really open. In other words, if you're a member of AAS, you can participate in any LAD function. You don't necessarily have to be a LAD member.
Okay.
Such as, go to our sessions at conferences, submit abstracts to talks, even be nominated for an award. You don't have to be a LAD member.
Okay.
But of course, we would like it. Some benefits, or even other benefits from LAD, you don't have to be a member. We have a listserv, which sends out announcements that are LAD kind of related positions and upcoming meetings and things. And we have a monthly blast of laboratory astrophysics publications that are published by AAS. We go through all the AAS journals and find relevant papers.
Got it.
And as long as you're on our listserv, you get that. But being a member of LAD itself, is an opportunity for networking with people beyond astronomy, even chemists, surface physicists, and other atomic molecular type people. That's one of the main benefits, I think, of being in LAD. And you're aware of all the activities that are going on from our members.
Right. So let's see if I had to. So there's sort of the science benefit of collaboration, right? You'll meet people of kindred mind, even if they happen to do, computation of 2-photon processes, or just networking, right? Because if you're going to be looking for your next position, it can be really great to have that social network of people you've met and perhaps worked with who can be aware of you and help you move on in your trajectory.
Exactly. Yes. Yep. And we are particularly, encouraging early career scientists to get involved, even at our, leadership level.
Mm-hmm.
You don't have to be a member, but we prefer, if you become elected to the division, you should become a member.
You probably should be a member, right? It seems like a fair deal to me. Yeah, and so to younger researchers who might be listening to this, if you would, a good time to have an influence on a young division is to get in early while it is still young. It gives you a lot of opportunity to mold how things will look in the future for a science topic that you're presumably passionate about. So it gives you a ground floor opportunity. If you this is a startup, people. So if you want to get in and have an influence on a startup division, now's a good time to do it.
Good point. Yeah.
And
emphasize how new we are. I'm just the 4th chair of the division.
Yeah.
I wasn't there at the founding. I wasn't one of the founders, but Johnny come lately, and I just jumped on.
It would seem like a good choice given your research activities to currently be chair. When did you get? So you've been in about a year, you said?
Well, I was vice chair for 2 years before, so it's the third year I've been in the leadership.
Right, and for those who are listening to this series, we'll have an interview with the current vice chair, Murthy Gudapati. That will be coming out in the next day or so, so be ready and listening for that one. And then we'll also, the following one, will be hear from the LAD secretary, Rachel Smith. That'll be coming out in a couple of days. And so we've got a whole series of LAD associated videos coming out in the run up to AAS 236 plus LAD meeting. So, so one final question, is there any final thoughts you'd like to share about LAD with potential new members?
Well, I mean, we've covered a lot of territory here. We're a new and growing division. And, we have our roots from the beginning of astronomy, but it's really exciting time for laboratory astrophysics because while it's an exciting time for astronomy, all of the new missions that are being designed will have improved resolution detectors, which really puts a lot of pressure on laboratory astrophysics to improve the quality of the data from spectroscopy to collisional processes to chemistry, everywhere from the radio to X-ray. So there's a lot of need for improvement and even availability of certain data, such as neutron star mergers.
There you go.
Are process elements which have hardly been studied. The bottom half of the periodic table. Right. We know very little about the spectroscopy of most of those elements.
True statement. Yep, that is a very active topic, I would say, with what they're submitting on manuscripts, right? We don't know the opacity of those materials, for example, very well. We don't know the transitions very well. And so that is a hot, active topic. And so for those of you who are doing our process calculations of kilonova or neutron star mergers, particularly of actinide, lanthanide materials, consider joining LAD.
Yep. It's starting to become a focus. A number of LAD people.
Warm home.
Yep. Now we mentioned that we had planned for the summer meeting to have a reception, which any AAS member could attend. So we're going to do this in the winter meeting.
Oh, okay.
As a way to try to recruit new members, just have a reception one evening for anybody at the meeting they can attend.
So this will be in Phoenix in January of 2021, I believe. So Phoenix is where I'm currently at, so I don't need to travel too far to get to the AAS winter meeting this time, which can be a good thing, I guess, in the current epoch. Very cool. So people, join LAD. And if you happen to be going to the 236 summer meeting, go ahead and listen into some of the sessions. We'll be highlighting, showcasing these videos in the AAS publishing booth. And go ahead and visit the reception at the 237 winter meeting in Phoenix. So Philip, I want to thank you so much for your time this afternoon and chatting with everyone about laboratory astrophysics and LAD.
Happy to do it.
All righty. Thank you, everyone. We'll see ya. Bye-bye.
Everybody this summer.